Fourth day session. Good morning to one and all present here. Welcome to fourth day session on SPSS by Dr. N. Sansanwal sir. Welcome you sir.
Thank you very much. So do I begin? All
Yes
right.
sir.
Good morning to all participants. I am sure you must be understanding, and because you are understanding, there might have been some questions. So therefore, I request all of you that do not hesitate to ask a question. Whether I'm able to reply or not, if I will not be able to reply, I will tell you that I will give the answer of this question the next day. But 99% the questions which you will ask, I think I will be able to reply to your satisfaction. But some of the things you might be not understanding, because we have already covered lot of things, say related to hypothesis testing. It has already been covered under our first webinar of the 7 days. Research methodology, in fact, you have to understand right from step number one, point number 1 to point number the last one, A to Z. If you have not understood A part, you will not appreciate B part. And if you have understood A, B, you can understand C, and so on and so forth. Nevertheless, but ask question as many questions as you want. Now, yesterday I have covered one-way analysis of variance. Now today I will be covering the two-way analysis of variance. And my sequence of presentation is when to use two-way analysis of variance. Yesterday I did give you the example when to use one-way ANOVA. And so today I will take you to little higher, that is a two-way ANOVA. Then I will tell you the assumptions which your data must satisfy if you want to analyze it with the help of two-way ANOVA. After that, I will tell you what should be the wording of the objective. On the first day, I did tell you that wording of the objective must be pinpointed, because it is the wording of the objective that will help you to decide which statistical technique to use for analyzing the data. So here I will tell you that this should be the wording of the objective if you want to analyze the data with the help of a two-way analysis of variance. Then I will tell you how to formulate hypothesis, and then I will tell you how the analysis has to be done using SPSS. Some of you, if interested in doing analysis with hand, it is possible. It's not very difficult. And if you are interested in knowing the steps, then you can refer to the book, which right now I will tell you. One of the book is Experimental Design by Dayton. I repeat, Experimental Design by Dayton. Another is Experimental Design by Alan Edward. These two books are good books, and I'm sure you will be able to understand whatever is written in these two books, because the writers have written in simple language. So I will tell you the analysis and interpretation, and then I will tell you how to use SPSS in order to analyze the data with the help of two-way ANOVA. So I'm sure you have understood the sequence. So please follow my sequence, and whenever you think that you want to ask a question related to that particular point, you can note it down in your copy. You should always have one copy with you. I have, of course, one copy with me and a pen, so I keep on noting down whenever you are asking certain things. Okay, so we go to the first one, when to use. Now you can use two-way ANOVA if you have two discontinuous variable. So either you can say discontinuous variable, or you can use the word categorical variable. That means, say for example, you say residential background, it's a categorical variable. You say types of colleges, it's a categorical variable or discontinuous variable. You say languages, it is a discontinuous variable. You say subjects is a discontinuous variable. So there must be two discontinuous variable, and each variable must have at least two levels. Any variable which is a continuous one, which is a discontinuous variable, it will have minimum two levels. So the moment you say this variable is a discontinuous variable, that means minimum there must be two levels, but there may be more than two, but minimum is fixed, maximum is not indicated by the word discontinuous. Okay, so therefore you must have two variables, and these two variables must be discontinuous variable, and each variable must have at least two levels. And I have said, the moment a variable is a discontinuous variable, then the minimum number of the levels will be two, or minimum number of subgroups will be two. Okay, so that is. But when you have a two-way, you may have one variable which may have three levels. You may have another variable which may have two levels. It's okay, perfectly correct, because there are two variables. So therefore, each variable may have the different levels, different number of levels, but variables must be two. Then it falls under the two-way analysis of variance. Otherwise, it will not. Now I am giving you some example. For example, gender has two levels. One is male, other is female. The types of college may have three levels, like government colleges, like aided colleges, like private colleges. Okay, and there must be at least one continuous variable. In one-way ANOVA, I told you there must be one variable, and that must have minimum number of levels of three. I told you if there is a variable which has two levels, then you have a choice either to use the t-test, or you can analyze the data with the help of one-way ANOVA. The results will be the same, but when you have to do calculation with hand, it is easy to calculate the value of t. So it is easy to analyze the data with the help of t-test. But if you want to do analysis manually and you want to analyze it with the help of one-way ANOVA, you can definitely analyze, but you will take more time and it is possible you may commit some mistakes also. I'm not saying error, mistakes, because they can be rectified. Okay. But in the two-way ANOVA, if you want, you can do the analysis with hand, but it will be slightly complicated. The t-test analysis is simpler. One-way analysis of variance is slightly difficult. Two-way analysis of variance is difficult than the one-way analysis of variance. So as I go ahead with the different analysis of variance, the difficulty level will increase. So this is what is more important. So therefore, if you have to use the two-way ANOVA, you must have the two variables, and these are the discontinuous variable, and each must have minimum two levels, and along with it you must have one continuous variable. If you do not have continuous variable, then you cannot calculate mean, and then you cannot compare the mean. Okay, so therefore in order to compute mean, you must have the one variable which is a continuous variable. Now in case of experimental design, we will use the word dependent variable, and we will use the word there will be some independent variable. Today I may take one example which relates to experimental design, so you will understand it. Okay. Now the assumptions are: number one, normal distribution. These assumptions are the same as yesterday I told you the assumptions of one-way analysis of variance. Now there has to be normal distribution of which variable? Of either you say the criterion variable if you are doing a survey research, and if you are doing an experimental research, then you should use the word dependent variable. So your dependent variable or criterion variable, it must have a normal distribution in the population. And because this has a normal distribution in the population, and when you select a sample from the population, and if the sample represents the population, then the distribution of the variable will be normal in sample also, because the sample represents the population. If it does not represent, then the answer is no. The second assumptions I told you, homogeneity of variance. What is the meaning? That whatever are the differences in one particular group, the same should be the differences in the other groups. Okay, so if that does not happen, then it is not advisable to analyze the data with the help of two-way ANOVA. Maybe you can use some non-parametric statistics to analyze the data. And another is your criterion variable or dependent variable. The scale of measurement must be either interval scale or ratio scale. If you have a data on the nominal scale, then you cannot use the two-way analysis of variance. And the same thing I told you when I was talking to you about the t-test as well as about the one-way analysis of variance. So your data must be strong data. And the last assumption is there should be no significant outliers. I have explained you yesterday and day before yesterday also, outliers means there should not be the members of the sample who have extreme scores, either on the higher side or on the lower side. If in a group you have these extreme scores, then rest assured they will change your mean. Therefore, these extreme scores are to be taken out when you want to analyze your data. So any outliers, they should be taken out from your sample. And when you are taking out, then your sample size will reduce. If you started with 200 samples and by chance if 4 people have extreme one, so out of 200, 4 will be minus. So now your sample size will be 196. So when you will analyze your data, so you are analyzing the data of 196 people. Okay. All right. So these are the assumptions. So your data, if do not fulfill these assumptions, then two-way analysis of variance cannot be used. Now, let us say, how do we write the objective whose data can be analyzed with the help of two-way ANOVA? Yesterday, I gave you the wording of objective whose data can be analyzed with the help of one-way ANOVA. And now today I am giving you the two-way ANOVA. And here is one. Read very carefully. Here it is to study the influence. Once the word influence has come, that means this objective must be of a survey research because the word influence is there. Okay. And then to study the influence of gender, types of college, and their interaction. Whenever interaction has to take place, there must be two things. If the two things are not there, then no interaction will take place. So minimum two variables must be there in order to have the interaction. If there is only one person in a room and if he is talking loudly, can you say this is the outcome of the interaction? I'm sure the answer is no. Because he is just talking, as right now I'm just talking. And I am, of course, assuming that there are people on the other hand, they are listening to me. But if I am alone in the room and I am not on the webinar, and if I am talking, then it is not at all an interaction because there is no one in the room who will listen to me or who will respond to me. So for interaction, you must have minimum two. Okay. So in this particular one, it is very evident that from this, you will get the answer of the three questions. Or there are three objectives in this particular objective. What are those? One, you will find out the influence of gender on achievement in economics. Another, you will find out the influence of types of college on achievement in economics. And the third, you will find out the influence of interaction between gender and types of college on achievement in economics of students. So if you want, you can write 3 separate, or if you want, you can write 1. But when you are writing 3 separate, then the number should be 1A, 1B, and 1C. Because all these 3 are part of 1. So the analysis which you will do, it will give you the answer of the 3 questions. So I'm sure you are now understanding it. So if you want, you can write the objective like this. But if you want to write separately, then you can write like this, 1A. And this I'm writing by using the word mean. I told you that the statistical technique can only compare the means. Okay, it cannot do anything else. So therefore, if you are writing a research hypothesis and if you are writing a statistical hypothesis, for this 1A, you will formulate a statistical hypothesis because the word mean is there. But if you want to formulate hypothesis for number 1, which is on your screen, that is to study the influence of gender, types of college, and their interaction on achievement in economics of students. For this, you cannot have the statistical hypothesis. For this, you have to have what is called a research hypothesis. Why? Because the word is influence. Okay, so for first objective, if you are writing, I will write the hypothesis, and to test that particular hypothesis, of course, you will use the 2-way ANOVA, no doubt, but it will be a research hypothesis. Now for 1A, when you have to formulate, and I have formulated, I will show you, when you have to formulate, it is a statistical hypothesis in the null form. The second will be to compare mean scores of achievement in economics of students studying in government and private schools, colleges. Now see, from objective number 1, it is not clear that how many types of college you have taken. As a researcher, you know that you have taken 2, because you have conducted this study. But if you write the objective like 1B, then here it is very apparent, very clear that you are taking only 2 colleges, and you are taking one government college and another you are taking the private college. Okay, so you will find that in comparison to 1A, 1B are more pinpointed and they are clear. And if you want to write objectives like this, you can write, absolutely no problem. Technically, you are all right. Whether you want to write 1 or you want to write 1A, 1B. Now see, I told you that one objective will be for gender. So I have written for 1A, and another for types of college, you have written 1B, And now 1C is for interaction. And the interaction between what? Interaction between gender and the types of college. And the wording is to compare mean scores of achievement in economics of male and female students belonging to government and private colleges. Many times people find it difficult to write the objective for the interaction. In number one, it is apparent, so they are not very difficult because I have written to study the influence of gender, types of college, and their interaction. But when I am writing 1A, 1B, and 1C, then the wording is slightly different because I'm using the word mean. I'm sure you are understanding. So if this is my objective A1, either you can write 1 or you can write 1A, 1B, 1C. Let me take one more example. Now here, the second objective which I have taken, you can see the red word. It is effect. The moment you use the word effect, it will indicate that it is an experimental study. But in the first objective, I use the word influence, and that indicates that it is a survey study. So therefore, the appropriate use of the word will improve the quality of your research, because it will have practically no room for confusion. It will be very clear and people will start understanding and may start appreciating. Yes, that's good. Okay. Now, number two is to study the effect. And the moment I say effect, there must be one independent variable. An independent variable is methods of teaching. Okay, effect of methods of teaching. And I may have another variable. Of course, it is not called an independent variable, but it is called a moderate variable. So gender is a moderate variable. So to study the effect of methods of teaching, gender, and their interaction on achievement in commerce of students. You know, when the teacher teaches, when right now I'm helping you, I'm sure both male and female might not be understanding to the same extent. Yes, that happens. Okay, and that is why the gender is a very, very important variable. Whenever you have to do research related to the classroom. So I can have this as one objective, and if I want to write the three objectives, then I can write like this. 2A will be to compare mean scores of achievement in commerce of students taught through discussion method and lecture method. So that means methods of teaching will have two levels. One is discussion method and another is a lecture method. So I must have two groups. One will be taught with the help of a lecture method, other will taught with the help of a discussion method. Now the another is to compare mean scores of achievement in commerce of male and female students. So when you are taking two groups, in both the groups, there must be male as well as female. And if you have to use a sampling technique for such an objective, or even for the first objective, you have to use stratified random sampling. You cannot use random sampling. It has to be stratified random sampling or stratified proportionate random sampling. Anyone you like, no problem. So your objective will tell you which sampling technique you should use for selecting the sample. And I have seen people, they may have any objective, and when it comes to giving the information about the sample, they say random sampling technique was used, and that may not be appropriate. Researcher cannot use random sampling technique randomly. No. Okay, so I'm not now giving you more information about the sampling because I have already covered. Now the third objective will be to compare mean scores of achievement in commerce of male and female students taught through discussion method and lecture method. So either you can write objective 2 or you can write objective 2A, 2B and 2C. And decide yourself which one you think is more specific. I'm sure you will agree with me that 1A, 1B and 1C, these three were much better than 1. Similarly, 2A, 2B and 2C, they are very specific and as compared to 2. So now the choice is yours. So if you want, you can write the objective like 1 and 2, or if you like, you can write 1A, 1B, 1C, 2A, 2B, 2C. So I have given one objective where you do the survey and another where you conduct an experiment for answering the questions which are there in the form of objectives. Okay, we proceed now. Now we go to the next point, that is, if I have written the two objectives 1 and 2, 1A, 1B, 1C, 1D, okay, and 2A, 2B, 2C, 2D, for those, how will I formulate the hypothesis? Now just see. For the first one, it was to study the influence of gender, types of college, and their interaction on achievement in economics of student. That was the objective 1. And for that objective, the hypothesis is there is no significant influence of gender, types of college, and their interaction on achievement in economics of students. But if you want to write the hypothesis for 1A, 1B, 1C, then it is like this. 1A is there is no significant difference in mean scores of achievement in economics of male and female students. 1B is there is no significant difference in mean scores of achievement in economics of students studying in government and private colleges. And the C is there is no significant difference in mean scores of achievement in economics of male and female students belonging to government and private colleges. So I have formulated one is called a research hypothesis, whereas 1A, 1B, and 1C are called statistical hypothesis. And both these hypotheses, I have written it in the null form. Now, I told to my other participants while I was teaching them the hypothesis testing that the statistical techniques are meant to test the statistical hypothesis directly. Research hypothesis cannot be tested directly, so you have to first test the statistical hypothesis and then you can move to the research hypothesis. Okay, so therefore, sometimes people do not want to formulate the hypothesis in the research and they formulate in the statistical. Number one. Number two, all statistical techniques, they were developed for testing the null hypothesis. This is important. Okay, so therefore, if you are writing a directional hypothesis, no problem, you can still test it. But how they can be tested, of course, I will tell you when I take the example. I will take one example. For the second objective, the hypothesis is there is no significant effect of models of teaching, gender, and their interaction on achievement in commerce of students. If I want to write in terms of mean, there is no significant difference in mean scores of achievement in commerce of students taught through discussion method and lecture method. 2B, there is no significant difference in mean scores of achievement in commerce of male and female student. And C is there is no significant difference in mean scores of achievement in commerce of male and female students taught through discussion method and lecture method. So I have given two examples of objectives and I have given the correspondingly for those two examples of objective how the hypothesis has to be formulated, so that I have covered. We proceed further now. Now I will go to my SPSS, and before I go to my SPSS, I will take one objective, although I have given you two objectives, but I can take different objective, no problem at all. And then after that, I will tell you how the data entry has to be done. And you know that you have to do data entry of how many variables. I'm sure you are able to think how many variables data entry has to be done. And if your answer is 3, then it is correct. But if your answer is not 3, then you have not understood it. 1, because there are two variables which are discontinuous variable, and there will be one variable which is a continuous variable. So you have to enter the data of the three variables. Okay, so we have to enter the data. How it is to be done, just now I'll tell you. And then I will analyze it, and whatever will be the output of the analysis, from that particular output, how will I make a table? Yesterday I made a table and I did write the heading of the table. So I will again do today. So from the SPSS output, I will make the table and I will tell you how to test your hypothesis and how to further interpret it. So interpretation, when you are writing, the testing of hypothesis is an integral part of the interpretation. It is not a separate part. No. Sometimes people get confused that hypothesis has not been tested, because it is tested when you are writing the interpretation. So testing of hypothesis is an integral part of the interpretation. Okay. And then of course interpretation, and then you will get the. Now let us go to the SPSS. So now I am moving to the SPSS, and I'm sure all of you have the SPSS, and therefore if you want, you can use. But before that, let me write the objective. Okay, I want to write the objective, and so you can write the objective. So I'm writing objective, and I'm saying to, let me take for experiment, because if some of you are conducting an experiment, then you may be interested, or if you are conducting survey. So, okay, let me first give for the survey, and then if time permits, I will take one example for experiment also. So to study the influence, of, I'm taking simple gender, types of college, and their interaction on self-confidence of students. Okay. If you want, I can write these objectives, this objective in the question form, and when I write it in the question form, by using the word mean, then it may be 1A. And the 1A is to study, to compare, not study, to compare mean scores of self-confidence, confidence of male and female students. The 1B will be, if you write, you can write 1B or you can write B. It's one of the same thing, because it refers to the same. Then another can be, I will copy and paste so that will be to compare mean scores of self-confidence of students studying in government and private colleges. Okay. And the third I will say to compare mean scores of self-confidence of male and female students studying in government and private colleges. And now, so I will try to take both and try to tell you if you have written one, then how will you interpret? And if you have written mean, then how will you interpret? Okay. Now I go to the hypothesis. Now, when I write the hypothesis, then I write for one and the hypothesis for one will be there is no significant. Now I can say influence. There is no significant influence of gender, types of college, and their interaction on self-confidence of students. So therefore, this becomes the hypothesis for the first objective. Now, if you want to write the hypothesis for the 1A, 1B, and 1C, I'm copying, pasting, and then they will be something like this. So 1A will be, I'll say there is, I'm making slight changes. There is no significant difference in mean scores. And if I copy this and I paste to the other one, so now I will paste it here. I'll just, there is no significant difference in mean scores of self-confidence of students studying in government and this. And the sixth one will be the one. So here I take this and I copy. All right. Now here is the C1. That is, there is no significant difference in mean scores of self-confidence of male and female students studying in government and private college. Now here you have the two variables. One of the variable is your gender, and it has got two levels. Another is your types of college, or if you want to say colleges, I don't mind, because so the types of college, and then another here is the self-confidence. So you know, out of the two variables are the discontinuous variable. So now I go to my SPSS. Now this is the SPSS. So I first go to the variable view, and here I define the variable. Suppose I say gender and enter. The gender has got two levels, so I will put 2 here. And if I say 1 means male, Okay, if I say students, because these are students, and if I say to the female students, and then I say okay. Now the another is types dot of dot punch. Now here you have the two levels. One is what is called government, colleges. Another is private colleges. And another variable that you have to take is the self-confidence. Self-confidence, and now you enter, that's okay. So I had the three variables, and I have written their names here. So variable view, this is the one. Now I go to the data. Now I am just entering the gender one, and I can enter fast, but you should not take data like this. You should take the actual data which you have collected from the field. Every day I will repeat it, because otherwise some of you may say that Sansanwal did it like this, so why can't we do it? So because I am explaining you, that is why I am taking these examples, as your teacher also takes example when he teaches you. Okay, so suppose I have taken these examples. Say I have taken, for example, 30 is 66 males. Now I will put that this person whose serial number is 66, in which college he belongs. So I know I have the data, so I can enter. Say he belongs to the private one. So it is one, another private, then government, private. And like this, you can enter the data, absolutely no problem. But you enter whatever is in your sheet, the data which you have collected. Now, sometime you may make a mistake in entry. So before you move to the analysis, you have to make sure that your entered data are correct. The matches with your data that you have collected. Okay. Now I can enter the self-confidence. If the self-confidence, the maximum score, I can assume anything. If 30 is the maximum score, then I can enter the scores, and I'm entering the scores. Okay, 30 is the highest one, that's fine. I'm taking little time in entering the data. You might be faster than me. Never mind, just wait. All right, I'm about to complete now. Yes, my data entry is over. I hope all of you also have entered the data. And if you are not, please fast. Now, after entering the data, since I know from my objective that I will be analyzing the data with the help of two-way analysis of variance. So I go to analyze and I try to find out, is there anything like analysis of variance? Yesterday I showed you when you come to the compare means, you have here one way. So you do not have a two-way here and three-way here. So now you people should note down, whenever you want to analyze your data with the help of two-way ANOVA or three-way ANOVA, you have to go to general linear model. You have to go to general linear model, and the moment you go to the general linear model, you will get univariate, and you click on the new univariate. Now this is what you get on your screen. On the right hand side dialog box, all these are empty. So you should know which variable information must be shifted under which dialog box. Now here it is written dependent variable. Now this word dependent is all right, don't bother about it. Dependent means the variable whose mean you want to compute and for comparison purpose. So that means the dependent variable is always a continuous variable. So amongst these variable, the self-confidence is only the one which is the continuous variable. So you have to shift it here. Now, next you have fixed factors, and then you have the random factors. Do you think that gender comes under fixed factor or it is random? If you are thinking that it comes under fixed factor, then you are correct. Because gender is fixed. I cannot keep on changing my gender. That today I am male and tomorrow I am female and day after tomorrow I am this, and I can't do things like this. Similarly, if I am in the government school, it's not that today I am in the government school and today I go to private school and day after tomorrow I go. No, I cannot. So in social sciences, whatever the variable you have, all these are the fixed variable and they are the fixed factors. Okay, so therefore you have to shift gender under the fixed one, and you have to shift types of colleges under the fixed one. And the sequencing of shifting will depend upon the sequencing in which they are appearing in my objectives. You have seen in the objective, I wrote first the gender, so gender should come first here. Then there I wrote the types of college, then that should come second. You cannot, if you change the sequence, then in the result it will come in a different sequence. But when you are making a table, you have to make as per your objective. So whatever is the sequence in which that variable is coming in your objective, you follow the same so that it is easy. I hope you have understood. And now, so I have shifted my variables and everything is okay. Now we go to option. Now I want the mean of all these things. So therefore I can select and I can shift it on the right hand side dialog box. And since I want mean, so I say descriptives. I want mean, standard deviation, etc., etc. And if you want homogeneity of variance, you can do homogeneity of variance, no problem at all. Okay. And here, by default, the significance is 0.05. And I told you yesterday that maximum allowed error is 5%. So this will always be by default 0.05. You need not to change it because you cannot do more than 5% error, but less you can do, no problem. Less is no problem. Okay, now we continue. Now, under save, we are not saving anything. So therefore, I'm not interested. Next is a post hoc. Now, this post hoc, I cannot use because it is to be used if you have a variable whose levels are more than 2. That makes minimum 3. Then you use post hoc test. Yesterday, when I was explaining you one way analysis of variance, I had taken a variable where there were 3 levels and therefore post hoc test was used. So, and in this particular example, gender has got 2 and types of college also has 2. So I will not require to analyze my data with the help of post hoc test. So I just skip it. Then I go to the plot. Plot means that there will be a graph. And this graph is very, very, very important. Because if there is an interaction, then you need graph to interpret the result. So therefore, you should have a graph. If you are not using, don't bother about it. If you are using, then use it. Okay. No harm in taking the maximum information in the output. Because from the output, whatever information you want to use, you have a free hand to use it. Now, when I have a graph, I'm sure you must have plotted graph in your life sometime. There will be x-axis and there will be y-axis. Now, on the y-axis, there will always be the means of the dependent variable or means of the criterion variable, always on the y-axis. Now you have a choice on the x-axis and the separate line. Now, if I say that I want the separate line for gender and on horizontal line, that is the x-axis, I want my types of college. That means the government college and the private college. So this is what I have done. So I add it. Please do not forget to add. If you forget to add, it will not give you the graph. because it only will give you the graph only and only if you have done all operations correctly. So I have added. Now I say continue. I need not to go to the contrast. I need not to go to the model. Don't bother about it. Let me now, I have done all, do the analysis. Now this is the analysis you have got. Say here the first table which you see, of course it is on my screen. On your screen you will also have the same table, but the number which are there in your table may not match with my table. So here it is that the males are 35, the females are 31. The students studying in government colleges are 35, studying in the private college are 31. So it tells you the number. In the second, it is descriptive statistics. That male studying in government school, their mean is 16.1250 and standard deviation is 4.50 and total number is 16 male in the government, and males in the private are 15.00 and they are 19 people, and total is this. Similarly, the females studying in government colleges, their mean is 16.05 and the standard deviation is 4.96. The females studying in private colleges, 14.83 mean, and this is the and numbers are given there, and on the whole also given there. Okay. Now the Levin's test of equality of error variance. Now here you see the significance. It indicates that the error is 43.1%. What does it mean? It means the error is more than 5%. And when error is more than 5% and it is not significant, the meaning is whatever are the differences in one particular group, the same magnitude differences are in another group. So that means homogeneity of variance condition is satisfied. So this Levin's test of equality of error variance, it reflects that. Okay, now we go to the next. Now this is the table which is important for you people to understand, because the information given in this table, that is test of between subjects effects. Now from this particular table, I have to take the information. Since one of my variable was gender, so therefore I have to take the information of the gender. Okay, so this is the gender is there. And then next is the types of college. And the next is the interaction between gender and the types of college. And the next is the error. And next is total. Okay, so from the sources of variance, you have to take these. Now in the next column, you have type 3 sum of squares. So I want sum of squares of the gender, and sum of squares of the gender on my screen is 0.228 and 0.228 means 0.23. And for the types of college on my screen, it is 21.887, that means 89. And the interaction between gender and types is 0.03. And then the error is 1384.36. Okay, so this I have taken the information in respect of gender, types of college, and interaction between gender and types of college, and error. Now the DF value, since there are two levels of the gender, so DF is 1. There were two levels of college, DF is 1. And if I multiply the DF for the gender and the DF for the types of 1, then it gives the interaction, it is 1. So interaction is 1 and error is 62. Okay, and your total is the 65 is the total. Okay, so 65 is the degree of freedom for the total, because the total number was 66, so 66 minus 1. Now next is the mean sum of squares. Say the SS for the gender 0.228, it is to be divided by correspondingly degree of freedom, that is 1. So MSS value is 0.228. So that means it is 0.23. Similarly, the mean sum of squares of the types of college is 21.887. It is to be divided by 1, the correspondingly degree of freedom, and therefore the answer is MSS is 21.89. I'm taking because it is 887. Then for interaction between gender and types of college, the mean sum of squares is 0.03, and it is to be divided by 1, so it remains the same. Now for error, SS is 1384.36. This has to be divided by 62, and then it comes to 22.33. So this is how you should note down these values. And now we see the F value. So F value, first we see for the gender, and for the gender the F value is 0.01, and against it you have the significance, it is 92% error, because the significance here it is given 0.920, and it is to be multiplied by 100, so it becomes 92%. Okay, so it is not significant. Now for the types of college, the F value is 0.98, and against this the error is 0.326 multiplied by 100, that is 32.60% error, which is more than 5%, so it is not significant. And for interaction, it is 0.002. So 0.002, and here the error is 96.8%. So that means all the three F values are not significant in this particular case. Okay. Now let me show you the other outputs. The other outputs are, this is the grand mean, the overall mean it has. Now this is for male and female, the mean for male and the mean for female and standard deviation. And this is for the types of college, that is government college mean and private college and standard error. And this is the interaction between gender and the types. Okay, and now this is the plot. Now in this particular plot, if in this case the interaction, the F value for interaction is not significant, it means there is no interaction between the gender and the types of college, and there is no significant influence of interaction between gender and types of college on self-confidence, sorry. So therefore, and you can see that both these are parallel. So parallel means they do not meet. And when they do not meet, that means there is no interaction. Okay. So therefore, if there is no interaction, we will not bother about this graph. We will not use the graph. But if the interaction would have been significant, then we would have used the graph. Maybe I'll take one more example, and there, let us see if we can have a significant interaction. Okay. So therefore, I have explained you the SPSS output, and you see so much information is given. And if you do with hand, it will be really quite tough. Okay. Now I go to my testing of the hypothesis and say interpretation. So I go to my this sheet. Okay. So therefore, now, so I'll say that here the caption which I want to make is influence of gender, types of college, and their interaction on self-confidence of students. Now this is what is the caption heading I will like to have. Okay, I'm making it bold so that, and actually the length, if I can reduce, is much better. So I still can, I'm just adjusting little bit. Okay, that's fine, nice. If you like, I can do. All right. Now, see, this is the one. Now, it is up to you if you want to write the three objectives, because all three are part of one. Or if you like, you can write one, and that is the objective which I had written was this. So I can write this, no problem. So I'll say like this: the objective was, so this is what is the objective. So the objective was to study the influence of gender, types of college, and their interaction on self-confidence of students. Now, for gender, how many levels? Male and female were. I have to write in the past tense because analysis has already been done. The male and female were the two levels of gender. Okay. While government and private were the two levels of types of college. Okay, so male and female were the two levels of gender, while government and private were the two levels of this, were the two levels of types of college. Okay, thus the data were analyzed with the help of two-way analysis of variance. Or if you like, you can say the data were analyzed with the help of 2 by 2 factorial design ANOVA. So let me write that. With the help of 2 by 2 factorial design ANOVA. If you want to write two-way, then also it is correct. But if you want to write 2 by 2 factorial design, it's more pinpointed in comparison to two-way. So data were analyzed with the help of this, and the results are given in table 1, because every day we are writing table 1. So now I have to give table 1. Yesterday I gave you one heading of the table. Now today I am giving you a better heading. So if you like, you can use this heading. Now here I have to enter, and let me take it on the next page. So I will insert the table. So let me insert the table, and I will say auto fit. The first is source of variance. Is what I did yesterday. So here also is that. Next is the degree of freedom. Yesterday I said sum of squares, then mean sum of squares, and then it is F value. Now here, because these values which you have seen, none of the value is significant, so we need not to bother about that. Now, first was gender. So I write gender and I can put in the bracket A. Why? Just now I will tell you. Another is types of college. Or if you say type of college, the choice, all right, no problem. And this I can say B. And then I have to say interaction between gender and this. So instead of writing gender, I will say A interaction B. Okay, so that it is easy. Another is error. Another is total. Now, the DF, you know, for gender was 1. The DF for types of college was 1. For interaction was 1. And for error, it was 62. And for total, it was 65. So you see 62, 63, 64, and 65. And total was 66, so 66 minus 1. Now let us enter the SS, the sum of squares. For gender, it was 0.23, and for types, it was 21.89, and then interaction was 0.03, and for error, it was 1384.36. Now, for calculating mean sum of squares, I will divide the sum of squares for gender divided by the degree of freedom for the gender. So it is 1, so it is 0.23. It will remain as it is. Next will also remain as it is, 21.89. Next will also remain as it is, but next will change because 1384.36, it has to be divided by 62, and therefore the answer is 22.33. I hope you have understood. If you have not understood, let me tell you how I calculated mean sum of squares for gender. This I calculated the SS for gender, and I divided this by DF for gender. This is how I calculated mean sum of squares for gender. And how I calculated the mean sum of squares for types of college. And this was SS for types of college divided by DF for types of college. And MSS for error, it was very simple. SS for error divided by DF for error. So this is how I calculated this. And how will I calculate F value? F value will be MSS. MSS. There will be 3 value. MSS for gender divided by MSS for error. So this will be the F value for gender. Now, if I have to calculate the F value for the types of college, then it has to be MSS for types of college and divided by MSS error. It is the same. And if I have to do the interaction between the gender, I'll say A, interaction, say B. So then MSS for interaction, that is A, interaction B, and then error. So this is how I will get the F value. So the F value here is 0.01. And for the types of college, it is 0.98. And for interaction, it is 0.002. Okay. Now, these are the three. And if these are the three, so that's what the three F values, and none of the F value is significant. Now we go to the interpretation. Now here, since I have the three objectives, 1A, 1B, and 1C, 1A was influence. So it is done like this. I'll tell you, if you are interested in putting the number, say suppose if this was in your chapter number 4 and this was the third main and 0. So if it was 5.3.0, that means fourth chapter, and in the fourth chapter it is the third heading coming and this is the main heading, so 0. Then here now I can say, okay, let us write the what is known as the heading of this table. That this will be summary. Yesterday I gave you sources of variance. You need not to write sources of variance. You can write summary. Summary of 2 by 2. Summary of 2 by 2 factorial design ANOVA, factorial design ANOVA of here the variable is the self-confidence of self-confidence of students. Please do not just write summary of 2 by 2 factorial design ANOVA. No, this is incorrect. You have to write ANOVA of which variable is self-confidence. Whose self-confidence? The student. So that's what you have to write that. Now this should be the heading. So yesterday the heading which I wrote, if in place of source of variance, you can write summary of one-way ANOVA. If you like, you can write here summary of two-way ANOVA, no problem. But I have written 2 by 2 because this is more precise and it is easy to understand in comparison to the two-way ANOVA. Otherwise, technically, you are correct. Now, since in the objective, there are 3. So therefore, I can write now here is this is 4.3.1. because my mean I have written 4.3.0, so this is 4.3.1, and here I have to write influence. See, whenever it is 0, 4.3.0, then everything should be capital, and whenever it is part of that, then only the first first letter will be capital, rest will be this. So influence of gender on self confidence of students. So I can break it from here so that it looks like to be self confidence of students. That's okay, of students. Now I should start writing. And now I write from table 1. It is evident that the F value for gender is 0.01, which is not significant. And I told you, if it is not significant, you need not to write the DF, and you need not to write the level of significance. Now, what exactly is the meaning of it? Now, it indicates that there is no significant difference in mean scores of self-confidence self-confidence of male and female students, because the F value is not significant, and F indicates it has compared the mean scores of self-confidence of male and female, so that means that also is not. Now here, since I have talked about the mean, so if you like, I can now quote here my hypothesis, which is a statistical hypothesis. Or if I want to write the research hypothesis, then I have to write one more sentence. Let me first write mean, because I have written mean here. Thus, the null hypothesis that there is no significant difference in mean scores. I'm just copying mean scores of self-confidence of male and female students is not rejected. Now, please understand, Since I wrote mean, and after that, if I have to write the statistical one, then I can write statistical hypothesis, no problem. But if you have not written statistical, then I cannot write here statistical. Then I should write like this, that I'm keeping it red so that you can compare it. Now, since my second sentence is, it indicates that there is no significant difference in mean scores of self-confidence of male and female students. Okay, so gender on self confidence of students. They say, because the means do not differ, so that means there is no significant influence of the gender on the self-confidence of students. Now I say, thus the research hypothesis that there is no significant influence of gender on self confidence of students is not rejected. I hope you have now observed the difference as far as if you have to test your research hypothesis, then thus the research hypothesis in null form, please it is. The research hypothesis in null form that there is no significant influence of gender on self-confidence of student is not rejected. So it doesn't matter, your final finding will remain the same. But you must be consistent. So that's what you have to do. So if you want to retain that, you retain. If you want to retain the statistical one, you retain. The choice is yours. So I'm taking out the statistical one here because I want to retain that, so I can go like this. Now I have tested my hypothesis because I have written is not rejected. Now I say it may therefore be said that the self-confidence of students was found to be independent of their gender. If you like, you can write like this, or you can write, it may therefore be said, both male and female students were found to have self-confidence to the same extent. The choice is yours. Or if you want to write like this, the way I have done, you can do the same. Both will mean the same. So if you want to write that, let me write for you. It may therefore be said that both male and female students were found to have self-confidence to the same extent. Okay, all right. So this is the one, because there are three parts. Although you are writing one objective, but in reality there are three parts, so you cannot give one interpretation. So at the time of interpretation, you have to bifurcate them. In this case, it is three, so you have to bifurcate it into three. Okay, now we go to the next. I'm taking from here and I'm just saving some of my time. I will copy and paste. So this I'm changing because this is my 2, and here it is types of college. Okay. And then I'll say from table 1, it is evident that the F value for types of college, this F value was 0.98. So I'll say is please, if you are copying and pasting, then you should not forget to make the appropriate changes, like the name of the variable, like the values, etc. Okay, and is not significant. So which is not significant? It indicates that there is no significant difference in mean scores of self-confidence of students. Self-confidence of students studying in government and private colleges. Okay, so there is no significant influence of types of college on self-confidence of students. Thus, the research hypothesis that they, in the null form, that there is no significant influence of, instead of gender, I'll write types of college. On self-confidence, it may therefore be said that students studying in in government as well as private colleges were found to have self-confidence to the same extent. So this is how you have to do the interpretation for the F value, the second F value. Now we move to the another one. So now it is 4.3.3. Because this is 4.3.2, now I go to the 4.3.3. And now you know here is a interaction. So influence of interaction, and here because there are two variables, so the interaction is between two variables, so I should write influence of interaction between here it is gender, because the first variable which I have written is gender, so I should mention gender. And then I have and then types of colleges, okay, of students. Influence of interaction between this on self-confidence of students. Now this is the heading, caption heading, which you have to write keeping in mind your objectives and the sequencing of the variable. Whatever variable is coming first, writing it first. Whatever is coming next, you are writing next. And now here I say from, I can say the F value, I'm changing little bit so that if you want to change, you can change little bit in the interpretation. The F value for interaction between gender and types of college. The F value for interaction between this is 0.002, which is not significant. Okay, and then I write wide table 1, because this information is given in table 1. So because in the earlier case I wrote from table 1, but now here I am little bit changing, so therefore I can write like this. But do not forget to mention the table number. This is important, because if you have many tables, so people should not feel that which value you are taking from which table. So table number, if you mention, it will help the reader in understanding what you are saying. Now, if it is significant, then it reflects that there is no significant difference. There is no significant difference in mean scores of self-confidence of male and female students studying in government and private colleges. Okay. Now, so because I am referring to the research hypothesis, so I have to say, so there was no significant influence. So there was no significant influence. So no significant influence of interaction between gender and types of college on self-confidence of students. Okay, and thus the research hypothesis in the null form that there is no significant influence of interaction between gender and types of college on self-confidence of students is not rejected. At the moment you write the word is not rejected, that means hypothesis has been tested, and now I can say it may therefore be said that self-confidence of students was found to be independent of their interaction between gender and types of. So dear friends, this is how you have to write the interpretation, and the finding will be 3. From the first one, you can have a finding Oh, this is 2 and this is 3. Okay. The first one from the first one you are finding is that from here that male and female students were found to have self-confidence to the same extent. So I can copy here, okay, and I'm now writing the findings so you know how exactly it has to be written. So I'm helping you in writing also. So it will be 4.4.0 and you have to say finding. Okay, so and this of course you have to bold it so that now here you can say the following were the findings of this study. Okay, and then one you can say this, the second you can say this, that both students okay, and because there will be 3 findings, because there are 3, so you can write 1 2 3, no problem at all. And here is both, and the last one is this. So now I'm sure now you are understanding that it is not very difficult to take out the findings from your interpretation if you have done it very, very systematically. Okay, so these will be the findings, and therefore now you can go ahead with another one. Now, if you like, I can take one more example and I will take off experimental one, and let us see what objective do I write. And I am writing the objective, and that is the second objective. Suppose I say to study the effect of methods of teaching. Okay, and if you want again gender, we can take, or if you want any other one, doesn't matter. And their interaction on achievement in any subject, research methodology, statistics, mathematics, Hindi, English, Malayalam, whatever you want to write, no problem at all. Achievement in. I am fond of writing mathematics because I was once upon a time the student of mathematics. I'm fond of that. And their interaction on achievement in mathematics of students. And if you want to write 3, you can write 3, no problem. I'm not writing to save time. And for this, what will be the hypothesis? So now I'm writing the hypothesis for you. There is no significant. So there is no significant effect of methods of teaching, gender, and their interaction on achievement in mathematics of students. Now see, here I have written the treatment first. Whenever you do an experimental study, the treatment must be mentioned first. After that, you can mention all other variables, whatever you want to have, no problem at all. But do not mention the gender first and methods of teaching second. No, you should make, because it is an experimental study. So that is why you should do the like that. Okay. Now let me take the data, and I will take the data. I'll first go to this, and I will first here say methods of teaching. Okay, say I'm taking here the two methods of teaching. Say one, I can say discussion or anything you like. Discussion method. Next, I'm taking say lecture method. Okay, and next now I'm taking achievement dot in dot mathematics. Okay. Now I go. Now here I have to enter my data. Okay, so let me enter my data. Now suppose I want to first the enter data of the experimental group, so I can write 1, 1, 1, 1. And now if you have to enter, you can copy this and you can paste it so that it is fast. As many subjects as you want. So now you can see it is easy. Okay, and if you want only so many people, then for the second one. And then again you can copy and you can paste it as many subjects as you want. So you see, if you do like this, then it is, but when you are entering your data should be arranged like that. For take all of the experimental group data separately and control separately, and then you do. Okay, that's what people do it. All right. Now here I'm taking the maximum score is say 50. I'm taking say 30, 50. I'm taking, but you can see anything. If you want 40, all right. Let's say maximum score is 40, and then now I am entering the data. I'm sure you are entering your data along with me. And dear friends, you need not to have equal number of the subjects in the experimental group as well as in the control group. No need. You may have it differently. Because sometimes people ask, should we have equal number? The answer is no. Because the SPSS will take care of unequal cell size when the number of observations in each cell differ. So that is called unequal cell size. If the number of observation in all the cells is same, then it is called equal cell size. Now here, since I have a factorial 2 by 2, so there will be 4 cells. Okay, on one it is say discussion method, another is lecture method, one is male, other is female. So on one side you have, so you know there are 4. All right. So let us go to I go to analyze, and then I go to the linear one and this one, and I am resetting this one. Now I have achievement in mathematics, and I have the methods of teaching here. And of course, I have I'm sorry, I have to enter the genders also because I did not complete. All right. So now I have the gender score also 77 and this also 77, perfectly correct. Please make sure that complete data you have, otherwise you cannot do it. All right. So here I have the achievement, fine. Then I have first is method of teaching, and next I have to take gender, and both are fixed, because when you are teaching a particular group with the help of a discussion method and another group with the help of a lecture method, so these are fixed one. So let us go to options. I want the mean of each and everything. Then I want this and homogeneity of variance if you want. Save nothing. Post hoc I don't want to do because there are two. And now here methods of teaching, I may take it and separate lines here, because in the y-axis you will get the mean scores of achievement in mathematics. I continue and I have, this is my result. Now I go to this. Now please see here. Here it is very clear in front of you that here for the methods of teaching and for the gender and for the interaction and for the error, okay, and the total. Now you know your the methods of teaching, the sum of squares is 948.81. 948.81. You might be having a different output, so don't worry, just keep on watching. And for gender it is 1.32, and for interaction between method of teaching and gender is 31.359, so I can say 36, and the error is 2761.95. okay, and I need not to write for the corrected total, no problem. Now go to DF. Now DF will be, it is 111, but for error it is 73, and for this it is 76. Now you have the mean sum of squares. Now mean sum of squares is 948.81 for methods of teaching, for gender 1.32, and for interaction 31.36. You can see it here. And for the error it will be 31.359. So it, No, it is 37.835. So it is 37.83. Now the F value. For methods of teaching, the F value is 25.08, and you can say that this F value is significant because here the level of significance is 0.000. Okay, so therefore this value is significant, and it is significant at 0.01 level. Okay. Now next F value for gender is 0.85. So 0.85, and for interaction is 0.37. Okay. Now let us go to our interpretation. So one value is now significant here. And let us see how do we do it. And you see the other values which are here. And now you see this. Now according to the F value for interaction, it is not significant. But when the graph comes, now you can see that they intersect. That means there is a interaction. This might be because of some other reason. So you will only interpret the interaction graph when the F value for interaction is significant. If the F value for interaction is not significant, then you should not interpret the graph. I hope you have understood it. Now we go to the interpretation part. And now I am here. Okay, I can little bit adjust so that it is fine. Now, before the finding, I have to write. So this finding, it cannot be 4, it may be 5, because 4.4.0 will be. Now the main heading which I wrote here, you know what the main heading was? This was the main heading. I hope you know this. Where this has gone? ANOVA of self-confidence. Okay. This is, I'm making up for the, I don't know, it must have been deleted by mistake. Okay, so now I have to write, see how I wrote 4.3.0. Now I cannot write the word influence because it is an experimental one. So in case of experimental, now here I have to write effect. Effect of methods of teaching. Okay, gender and their interaction on achievement in mathematics of students. Okay, now this is the heading and it should resemble with your objective. So therefore the heading must be in consonance with your objective. So whatever is the objective, from that you have to take. Now I can just copy paste the objective. So I'm just going here and I'm copying this so that my task is slightly simple. And now I said the second objective. Okay. The second objective was, now I can copy and paste, was to study the effect of methods of teaching gender and their interaction on achievement in students. Okay, discussion and lecture were the two methods of teaching, while male and female were the two levels of gender. Thus, the data were analyzed with the help of 2 by 2 factorial design ANOVA, and the results are given in table 2, because the table 1 we have seen, but if you are writing it in a chapter, since here we are writing the 4th chapter, so I can say 4.2, and earlier I could have said 4.1. So therefore you can make that changes. Now here I have to have a table, so I'm going to the next one. So table, I'm saying this, and let us say how to insert the table, and I'm inserting the table. Okay, the first is source of variance, next is the degree of freedom, next is sum of squares, next is mean sum of squares, and next is F value. Okay, and here now since one value is significant, so I should have one more. And here this I will put remark. And here my first is methods of teaching. My second is gender. Gender is B, and my methods of teaching, I can put A, no problem at all. And next I can say A interaction B. Next I say error, and next I say total. Okay. Now here degree of freedom is 1, 1, 1. And for error it is 73. And for total it is 76. The SS value 948. So it is 948.81. I have noted down on my separate page. And for gender, it is 1.32. And for interaction, it is 31.36. And for error, okay. Let me just make a little bit, I'm making the font size little bit small so that, okay, now it is all right. Okay, now the error is with me 2761276.95. Okay. Now mean sum of squares 948.81 as it is. Okay, I have to further reduce the, all right, I will reduce. No, I have no other go if I do not reduce it further. I'm sure you will be able to see it on your screen. And this is 1.32 and this is 31.36, but for error it is 37.83. 37.83. Okay. Now the F value for methods of teaching is, it is 25.08, and this is significant. So it is p value is less than 0.01. So please see that this p, you should make it small, not a capital one. Now, then my other value is 0.85. Another value is 0.37. Oh, sorry. This is 0.37. Okay. Now here it is summary of 2 by 2 factorial design ANOVA of, here it is achievement in mathematics. Achievement in mathematics of students. Mathematics of students. Okay. Now, so everything is in front. Now we have to start writing the interpretation and test your hypothesis. So I'll say 4.4.1 is, so here I say the 4.4.1 is, it is effect of methods of teaching, effect of methods of teaching on achievement in mathematics of students. Okay, all right. So now now you say that from table 2 I'm I'm just changing. Okay, so from table 2, it can be seen that the F value for methods of teaching is, oh, I did not write the other F value, so I should write the other F. Oh God, these I wrote in the wrong one. So please make a correction. They should be here, not here. I'm sorry. This is what happens when you are fast. All right. And both these values are not significant, so I'm not writing anything, because if you are not writing anything, then they are not significant. But by chance, if your supervisor or guide, he says, no, you should write, then it is not significant. So you can say NS, N dot S. Okay, and N dot S. And then here you should write N dot S means not significant. But if he does not insist, please don't write. Because when you are not writing anything, it is understood that these values are not significant. But if he insists, then you can write, no problem at all. Choice is yours. Okay. So from table 2, it can be seen that the F value for method of teaching is 25.08, which is significant, at 0.01 level, with DF equal to, no, here you have to write 2. One for the method of teaching is 1, another for error, which is 73. Okay, and full stop. So from table 2, it can be seen that the F value for methods of teaching is 25.08, which is significant at 0.01 level. Whenever it is significant, you must mention the level of significance as well as the DF. If it is not significant, then you need not to write that. Now, it indicates that there is a significant difference, or you can say it indicates that the mean score of achievement, that also the choice is yours. Let me write it slightly differently. It indicates that the mean scores of achievement in mathematics, I'm copying paste so that it's mean scores of achievement in mathematics of students taught through discussion method and lecture method, differ significantly. So there was a significant Please see, here I must use the word effect, not influence. So there was a significant effect of methods of teaching on achievement in mathematics of students. Okay, thus the research hypothesis in the null form that there is no significant effect of methods of teaching on achievement in mathematics of student is rejected. Please see, because the means differ, so therefore the hypothesis, research hypothesis in the null form is now over. Okay, so therefore you can say now after this what you should do is you should go to your output and find out that which group mean score of achievement is in mathematics is higher. So if you go here, you will find these are your discussion method students, and the discussion method students, the mean scores of achievement is 26.41, and of the lecture method is 19.28. Okay, so therefore you can do like this, so you know them. So let us go. Now here it is further the mean score of achievement in mathematics of students taught through discussion method is 26.41, which is significantly higher than those of lecture method group, whose mean score of achievement in mathematics is 19.28. Now you must mention the means. This is important, because if you do not mention the means, then people may not be able to understand what was the mean, and therefore you have said this is higher, then how much higher, and things of that variety. Okay, so you should further the mean score of achievement in mathematics of students taught through discussion method is this, which is significantly higher than those of lecture method group, whose mean scores of achievement, it may therefore be said, that it may therefore be said that discussion method was found to be significantly more effective in comparison to lecture method on the basis of achievement of students in mathematics. Now this becomes your finding, dear friends, that when you take from here and you can copy and paste. So I'm copying and I'm pasting. This will be the fourth finding. So I can put it, this is my fourth finding. So this is how your findings also simultaneously you will be having. Now I have to write the other also. Now the other one is, it is 4.4.0 and it is influence. No, it is because here this is a moderate variable. So if you want to retain a uniformity effect, you can. If you want to write influence, you can. Because the gender cannot have a effect, it is a influence. So if you want influence, you can, or if you want effect, it does not make a difference. Anything you can write. So effect of gender on achievement. Oh God. Effect of gender on achievement in mathematics of students. Okay, now here you have to say from table 2, it is evident that now you know that because the value was not significant and I have already interpreted a value of f which was not significant, so the interpretation is of the same type, there is no difference. So it is evident that that f value for gender is 0.85, which is not significant. Okay, now I need not to write the level. It indicates that the mean scores of achievement in mathematics of students, of male and female students, male and female students did not differ significantly. Now, if I want, I need not to write the research hypothesis in the null form. I can also write directly null form, thus, because whatever is the hypothesis you are writing, it has to be written in the null form. So I can say null form, no problem at all. I'm telling you these variations because some of the guides may like to have that variation, okay? Otherwise, perfectly correct. So therefore, so it means, it indicates that there is no significant influence of gender on achievement in mathematics. Effect of gender on their achievement in mathematics. Okay, thus the null hypothesis that there is no significant effect of gender. Since in the heading I have written effect, that is why I am writing effect. Otherwise you can write influence, no problem. But in case of treatment, you cannot write influence, you have to write effect. So thus the null hypothesis that there is no significant effect of gender on achievement in mathematics of students is not rejected. It may therefore be said that achievement in mathematics was found to be independent but found to be independent of the achievement in mathematics of students, are found to be independent of their gender. Either you can say this, or you can say it may therefore be said that both male and female students were found to have achievement in mathematics to the same extent. The choice is yours, absolutely no problem. Okay, so therefore if you want this as your finding, so you can copy and paste, and now you can say now your fifth finding is something like this. So let us go, and now I'm writing my last 4.4.3, and here effect of interaction interaction between methods of teaching, not treatment, between methods of teaching and gender on achievement in mathematics, so I can bifurcate this from here. I'm adjusting the caption heading little bit, and I say this. Okay, all right. Now if you want, you can write the F value for interaction between methods of teaching and gender is 0.377, which is not significant. And here I say wide able to. Okay. Now it indicates that the mean scores of achievement in mathematics of students. Mathematics of students taught through a discussion method and lecture method Okay, it indicates mean do not differ significantly. So there was no significant effect of interaction between method of teaching and gender on achievement in mathematics of students. Is not rejected. No, I can't say not. So there was no significant effect. That's okay, fine. Now I have to say about my hypothesis. Then as I told you, I need not to write research. I can just say, thus the null hypothesis, because you can write research hypothesis in the null form or directional form. You can write statistical hypothesis in the null form and directional form. So no problem, but this is important. So there was no significant effect because mean is first and then this, and then you can say thus the null hypothesis that there is no significant effect of methods of teaching. There is no significant effect of interaction between method of teaching and gender. There is no significant effect of interaction between method of teaching and gender on achievement in mathematics. Achievement in mathematics of students is not rejected. Yesterday I told you we cannot write accepted and you can write accepted provided you have collected the data from all members of the population, and which is never done in the research. So therefore you have to write the word not rejected. Let me see what it is in mathematics. All right. Okay. Now it may therefore be said that achievement in mathematics, that achievement in mathematics of students was found to be, what has happened? It may therefore be said that that where is the achievement? It may therefore be said that achievement in mathematics of student was found to be independent of interaction between methods of teaching and gender of students. Dear friends, this is how we should write when there is a value which is significant. This is how it has to be written. And if it is not, then no. And from here, if I copy, then it becomes the finding, and I can write the finding. So there were 6 findings. So therefore, that's what. So I hope you people, if not very clear, at least there is a little confusion. And confusion is the first stage of learning. So that means you have learned. Now over to the organizers. Yes, please.
Thank you so much for your valuable information. Sir, we'll take a few questions.
You take as many as you like. No problem.
Yes,
okay.
So, kindly take one example of field experiment having treatments, design, CRD or RBD, etc. with replication. So we can know how to analyze it through SPSS.
Okay, please, today I cannot take it. If you want, then it makes you should know the experimental designs. And when you are taking the experimental design, either RBD or CRD, then the analysis has to be done very differently. So here, I do not think I will be able to help you out to take the data and then do it. No, I cannot do it right at the moment. If you want, I can help you out. If you send your data, I can analyze and send it back to you. Next question.
Please take one example from experimental subject.
I have taken example from experimental subject. Just now the example which I gave, the methods of teaching, it is experimental.
Okay.
Next.
Sir, provide one example of data analysis based on research question and how to its hypothesis formulation.
Please, I have been telling time and again, your research question is nothing but your objectives. Okay, and hypothesis formulation wording remains same whether you are writing from research or questions or you are writing from objective. It does not make a difference. Say if I take one example, say suppose my objective is to compare the mean scores of achievement in mathematics of male and female students. This is my objective. So I can write a research question that what is the difference between the mean scores of achievement in mathematics of male and female student? This is in the question. My hypothesis remain the same. The hypothesis will be there is no significant difference mean scores of achievement in mathematics of male and female. So it doesn't make a difference. It's one of the same thing. So this is how you can write. Next.
Sir, how we can know that data is normally distributed or not? Can we know by seeing data?
No, you have to compute what is known as the kurtosis. And when you compute the kurtosis value should be 0.286. If it is near 0.286, your data are normally distributed. And or another can be you compute mean, median, and mode from the same data, and if their values are quite close to each other, then you can say they are, of course, the distribution is normal. You can do that. Next question.
Okay, sir. Sometimes we may get outliers. How to eradicate these outliers with the help of SPSS?
No, what you do is you eradicate, just take out their values. Do not consider their values when you are analyzing it. So when you are entering the data into the SPSS sheet, do not enter the data of the outliers, means those people who have higher scores and those people who have low scores. Don't enter the data. That's all. And if you do not enter, then their data will not be considered at the time of analysis. Next question.
Okay. If I have to enter data like length, weight, etc., such as 12.3 centimeter, 15.5 centimeter, or 6 gram, 4.2 gram, etc., how will I enter such data in SPSS?
No, it is very simple. Okay, I'm going to the SPSS, madam. Do I go with your permission?
Yes, sir.
Okay, I'm say this is my data sheet, and if I have to enter the, let us say, weight, this is my weight will be in kg and all that. Now I go to my data view. Now here I can enter the data, say 45.89 kg. I can enter, say 65. Okay, say
Okay.
7.8. This is how I can enter the data. Data entry is not a problem. I hope you have understood, the person who asked me the question. Next question.
Okay. How to interpret the standard deviation?
You need not to interpret the standard deviation. Standard deviation only indicates the differences within the group. And there will always be differences within the group. So standard deviation is not to be interpreted at all. You interpret the mean. Okay, standard deviation is computed because you have to compute other statistics, and for their computation you need standard deviation. Otherwise, the interpretation of the standard deviation is, if your standard deviation value is more, whether it is more than the mean or not, if your standard deviation is more than the mean, it means that whatever the, if it's an experimental study, that whatever the treatment you have given, this treatment did not benefit everyone equally. For example, the webinar lectures, maybe all the students may not be understanding everything to the same extent. No, it is possible they may not be understanding. So that means the standard deviation will be larger than the mean. When a mean is larger than the standard deviation, that means majority of the people have understood. Next.
Sir, when we used error bars in graphs, and in error bar, what we can use? Either SD or S error, standard deviation or S error.
No, it is SC, standard error.
Okay.
Next.
In descriptive research, which type of variables we can use?
You can use as many variables. Say, for example, you have the problems, you have adjustment. Okay, you have your many examples I gave earlier, so you can have like that, no problem. You say problems, you say adjustment. Okay, these can be the different variables where with respect to which you will have your data in the quantitative form. But if it is descriptive research, this is all characteristics with respect to which you want to describe, you can have them. Next.
Okay. Sir, in which type of scale comes the 3 and 5-point rating scale?
Actually, when you have it data, when you have the variable, either your variable will have a test, or it will have a scale, or it will have a inventory. So when it is a scale, your scale can be either a 5-point scale or 7-point scale or 3-point scale. So therefore, the 3-point or 5-point, they comes under the scale, and the data which you will have will be quantitative in nature. And many a times people call it a rating scale, but it is never a part of questionnaire, because some people, they put scale as a part of questionnaire, and they write questionnaire, and in fact it is a scale. So they should not make such a mistake. Next question.
Okay. F values of gender is zero point 0.01 and of interaction is 0.002, which are lower than 0.05. Why these are not significant?
No, they are, you cannot compare, my dear friend. F values cannot be compared. You can't compare, and there is no association between them. Next question.
Okay, sir. If F value is zero point 0.01, then why it is not significant?
You see, F value is 0.01 because this value has to be compared with a standard value, and the standard value is higher and this calculated value is lower. And that is why in this particular value, the error I did mention, this is the error, and error has to be uh, either 5 or less than 5, then and only then the value is significant. If the error is more than 5%, then the value is not significant. The error is very high, so it's not significant. And if you want to see those people who are interested, they should go home. Okay, they should take out their books on statistics, and then they go to the say appendix side, and there it will be the F value and or analysis of variance, and there they can find out the table value, and they can compare their calculated value with the table value. Next question.
Okay. Sir, when should we say that the F value of any given variable is significant?
Say, okay, all right. That means you people do not know basics. Now you people should take out your pen and pencil. Now I tell you, see, when for the given degree of freedom, if the F value is less than the table value given under 0.05 level, then the calculated value is not significant because the error is more than 5%. So this is the one rule. The second rule is, for the given DF, if the calculated value is either equal to or greater than the value given under 0.05 level, less than the value given under 0.01 level, then the value is said to be significant at 0.05 level. The rule number 3, for the given DF, if the calculated value is either equal to or greater than the table value given under 0.01 level, then the calculated value is said to be significant at 0.01 level. These are the rules which you can apply and you can find out whether your calculated value is significant or not. Next, madam.
Okay. Sir, sometimes graphs shows interaction, but F value is not significant. Why?
Because the graph might show interaction because of various other intervening variables which we have not taken into cognizance when we were conducting the research. So that can happen, and it is therefore very important. First of all, you have to see the F value for the interaction. If the F value is significant, then and only then you should interpret the graph. But if the F value is not significant, then you should not interpret the graph, because the graph which has come, it is not just because of the interaction between these two variables. There might be other intervening variables which we have not considered in this particular case or in your research, and it's because of those variables in the graph it shows interaction, but in reality it is not interaction. So this is the explanation. Thank you. Next question.
Okay, sir. Showing p-value or significance is not necessary in table.
No, see, whenever the showing p-value or significance is not necessary, no, it is necessary. You have to show. If the value is significant, then only then you should show. If the value is not significant, you cannot show, because it is understood that the value is not significant at 0.05 level. So it is understood whenever you say the value is not significant, that means it is not significant at 0.05 level. No need of showing. You should not show whenever it is not significant, but you must show whenever it is significant. Next
Okay,
question.
sir. Can we add one more column in table, that is inference?
You see, you cannot write inference in the table. Nowhere the inference is to be written in the table, so you should not add another column. But whenever you want to add column, you can add as many columns as you like, but for inferences there is no space. You cannot write inferences in the table. It has to come in the interpretation. It is a part of the interpretation. Next.
Okay, sir. How does the research objectives given today? It is fulfill the assumption of two-way ANOVA?
How does the research objective given today is fulfill the assumption? I have shown homogeneity of variance. I have shown. So homogeneity of variance was there. Therefore, that's okay. Normal distribution is there, because the variable which I have taken, they are normally distributed in the population. So its assumptions are fulfilled. No problem. Next question.
Sir, one last question. Can you please define F value and P value?
P value means it is the level of significance, and F value means it is the ratio of mean sum of squares of treatment to the mean sum of squares of error. It is the F value. On the basis of F value, you have to compare it with the standard value, and then you can find out P value. P value means level of significance. And the level of significance you cannot find out without comparing your calculated value with the table value, because in the table values, the p values are given or level of significance is given. So your p value depends upon your f value and the degree of freedom. Next question.
Okay. Okay, sir. Thank you so much for your patience, for your valuable time for answering all these questions. Indeed, it was an excellent session today also. Thank you so much, sir.
Thank you. Okay. Bye bye.
Bye, sir.
I'm leaving.